All right, really quickly, I'm just going to review with you what you should have in your blue book for our test for Tuesday. Basically, we have 3 different places an angle can lie, and then we have 3 different types of segment problems. All right, so some things that we need to have or that we need to review. If I have an angle and its vertex is on the center of the circle, then it equals its arc. So if the arc is 80, the angle is 80. But if I have an angle who's inside the circle, but whose center is not at the center, then I average the arcs. So in other words, to find this angle here or this angle here, I'm going to average the value of these 2 arcs that are intercepted by the x. So if this was, say, 100, and this was 50, then the angle would be the average of those 2. It would be 75. All right, so those are the 2 cases where it can be in. There are also 2 cases where it's on. So the first case where it's on is when it's an inscribed angle. And that intercepts this arc here. So let's say that that arc is 60. Well, it's inscribed angle down here, this angle down here, that's going to be half of it. So that angle is going to be 30 degrees. So when it's inscribed, it's half. The other type that we have that's on the circle is when I have any chord intersecting a tangent line at the point of tangency. It doesn't have to be just a diameter, any chord. And I want you to notice that this is the arc that's being intercepted, the one that the chord intercepts. And this angle down here made between the 2 lines or line segments is going to be half of that arc. So if that arc were 100, then I know this angle down here is 50. So again, the relationship is half here and half here. All right, and then we have the case where the angle is on the outside of the circle. I'm going to go ahead and go to another slide, and we'll go through the 3 cases for that one. All right, so for our first case, if we can have 2 secants. So if I have 2 secants, I want you to notice that they intercept 2 different arcs, an outside arc and an inside arc. And this angle is always half of those arcs' differences. So in other words, if this outside arc is 100 and the inside arc is 50, then we would take 100 minus 50 divided by 2, and that would get us 25 for this angle down here. All right, case 2 is when I have 1 secant and a tangent. Again, there's 2 arcs that are intercepted. There's this outside arc, and then there's this inside arc. The rule is the same. So if this outside arc is, say, 260, and the inside arc is 100, I would take 260 minus 100 and divide by 2. And that's going to get me 60 divided by 2, which is 80. So that angle would be 80. All right, and the third case where it's on the outside is when we have 2 tangents. Again, I have 2 arcs. I have this arc and I have this arc. So let's say that the outside arc was 300. Well, then I know the inside arc has to be 60 because in the case of the tangent, we know we have the whole circle being used. So the 2 arcs have to have a sum of 360. But to do the actual problem, to find the angle, it would be 300 minus the 60 divided by 2. So in other words, 240 divided by 2, which is 120. And of course, the pictures don't always show what we think, but that in the 60 is obviously pretty big arc for a 60-degree arc. Okay, that covers all of our angles. Those are the things that you need to know. There are some theorems that just came from these, like some corollaries. For instance, if you do have a tangent and a diameter, then it's got to be 90 degrees because that would be half of this intercepted arc, which is 180. And so there are some things that come from this. But really, if you just know all of those rules that I just went through with you, you should be good. So 2 in, 2 on and 3 out. Know each of those rules, and they have the same formulas. It's just that you have to understand what they look like and what we use. All right. Then we did our different things where we dealt with segment lengths instead of angles. So we're going to go into those. Our first case for that was when we had what we called chord. So in other words, if you have two chords intersecting, and let's say the pieces of one are 3 and 6, and the pieces of the other are, say, 2 and x. Well, then we're going to go ahead and just do what we called part. So in other words, we're going to take the two parts of one, set them multiply them together, and set them equal to the two parts of the other. And then we're just going to solve it. So we would get 18 equals 2x, and in this case, x will equal 9. All right, we had another one that was 2 secants. And what we learned with the 2 secant problems was that if this was 3 and 5, and this was, let's go with x here and 2 out here, well, what we learned was that it was sec out equals sec out. So it's the whole secant, which is 8, times its outside piece, which is 3, equals this whole secant, 2 plus x, not times its outside piece, times 2. And I would get, if I solve that, 24 equals 4 plus 2x, or 20 equals 2x, or x equals 10. And our last thing for this was when we had a tangent and a secant. So a tangent and a secant meeting. This was the sec out equals tan squared. So let's say that this is 4 and this is 5 and this is x. Well, it would be the sec times the out equals the tan squared. So we would have 9 times 4 is 36 equals x squared. So for this case, x would equal 6. All right, and the very last thing we did was the circle. And we found that the equation for a circle is x minus something squared plus y minus something squared equals the radius squared. And that something was a point, HK. And we found that HK is the center of the circle, and R is the radius. So in other words, if I had an equation, x minus 3 squared plus y minus, let's go plus 4 squared equals 25, then I would know that the center of this circle is 3, negative 4, and the radius is 5. And that'd be really easy for me to go draw, because I can go 1, 2, 3, 4, sorry, 1, 2, 3, 1, 2, 3, 4, put a point, and then I can do my 4 north, south, east, west points from there. So I would go, if I'm down at negative 4, I'd go up to positive 1. I'd go down to negative 9. I'd go out to 8 and back to negative 2. And then once I have all of those, I can just sketch that circle. All right, come in and see me if you guys want to review before the test. Good luck.